This is Mafuchit, the modular air filter using cheap Ikea things. I found the cheapest filters around from a reputable company and designed this modular box to help you get rid of the gases that your 3D printer puts out that you shouldn't breathe. I'll show you why air filtration is important, how this fits into a holistic solution, and my design decisions along the way. Wondering how I did this window? That's in here too, so stick around to find out. Hi, I'm Fneb, aka Bethany, and welcome to my Goblin Nerd Cave. Please excuse the mess. Organising is one of my many ongoing projects, and it's very much a work in progress. Heck, I finished this project months ago, and I'm only just releasing it now. Life. Speaking of life, one thing that is not especially helpful to life is bad air quality, and 3D printers can be a serious source of aerial nastiness. These are my two printers. My GDX Plus 3 is fully enclosed but has more leaks than an actual sieve. And my Voron switch wire, I haven't finished enclosing quite yet, but I'm nearly there. I've not properly fit the doors yet, and my ADHD lost interest. A common reason to enclose a printer is to help with temperature and warping of some materials. But the ugly side of 3D printing is that it produces some pretty nasty gases. Sure, this depends on the material, but even community favourite PLA can produce byproducts you don't want to breathe. I mean, that's pretty true for a lot of modern stuff poisoning our environments, but there's only so much existential dread I can handle at a time. So I'm going to focus mainly on 3D printing. There's been a bit more recognition of this topic lately, with people like Thomas Sanladerer and Nathan Bill's Robots talking about the subject. But I still want to cover the why for this project's what. So let me cover the basics in brief, and with a couple of niche specifics. There are two kinds of nasty out there. Firstly, there's particulate matter, i.e. very fine dust. Some of it so small you can't even see it. Jacob of 3D printing company Construct 3D, in an interview with Nero the Canuck creator, described how he had found that properly set up polycarbonate V-wheels had a longer lifespan than linear guides because of ABS dust getting into the metal bearings of the latter. I once have thought of this stuff giving off dust. It wouldn't surprise me if at least some other polymers also produce this kind of dusty stuff. But either way, you probably don't want that same stuff in your lungs. This is where HEPA filters come in. They catch the particulate matter, ideally before your body does. However, that's not the only type of gross, gassy thing around. The other things worth filtering are volatile organic compounds, or VOCs, which are small enough to slip through HEPA filters and are generally on the stinky side of things. The smell is largely why I only printed PLA for years, and even no odour ABS is definitely not a smell I want in my home before considering the health effects. For VOCs, you need activated carbon or activated charcoal filtration, so properly filtering your air is a two-step process. Having your printer enclosed helps with some of this by constraining where the air can go, but it's nigh impossible to make a printer completely airtight, so some of the polluted air is going to seep out. Even if you did, there's still unhealthy stuff in there to jump out at you when you open up the printer to get your new Benchy. For the air that is trapped in the printer, having a recirculating air filter inside the printer's chamber is an important part of the overall solution. It circulates air around the enclosure, making it pass through the filter while the printer does its thing. Even with this upgrade, some filament farts will still escape through any leaky spots in the enclosure. A couple of good projects in this area are the Nevermore and the Bento box, but these have the downside of taking up space inside the printer and using quite small filters. Additionally, if the air inside the printer is kind of warm, this can affect how good the activated carbon is, potentially making it useless. Worse, depending on the charcoal, it can damage your printer itself, rusting up the shiny metal bits that make it work, which is kind of bad. The other way of filtering your printer's air is to eject it out of the enclosure and then filter it. You could just blow the air outside without filtering it at all, but then you're just passing all that foulness to Mother Nature, which is a bit rude.
That's pretty rude.
Mammals are actually quite resistant to toxic gases compared to the likes of birds, which is why we used to have canaries in coal mines. Maybe let's try not poisoning the world quite so much. I mean, we could get into the nitty-gritty of how HEPA filters themselves are disposable bits of plastic, but there's no morally pure solution to this. And if nothing else, it's nice to not have unpleasant smells going around. Given what we're up against, I think the best bet is to enclose the printer, use a recirculating air filter when all the doors are closed, and an exhaust filter on top. Keeping the exhaust filter on during doors closed prints like ABS, which wants to be in a warm environment, will help keep negative air pressure in the chamber and so stop nasty gases leaking out, with the recirculating air filter stopping the built-up gases getting too gross. On the flip side, materials like PLA and PETG don't want to be printed in a closed box, so we usually print without it being enclosed. But using an enclosure with doors open and a higher airflow filtered exhaust means we can keep both the heat and the horrid stuff that is in the air from building up and the flow of contaminated air away from us. It's actually this thought that is why I'm working on enclosing my switch wire, and I added an air duct exhaust to the top with a blast gate so I can close it off completely if I want, and eventually add it to the same ventilation system as my X Plus. I was going to keep it unenclosed for PLA and PETG, but if I can keep printing those, have more options for other materials, and reduce what may well be a serious health risk at the same time, well, it's worth doing. Great, so how do we go about filtering exhaust air? Building and hydroponic ventilation systems give us good options for air ducting and fans intended for moving air through them, so we can buy off-the-shelf parts there. But HEPA and carbon filters are consumables and need to be replaced quite often. You can't clean a HEPA filter, as it relies on an extremely fine mesh to trap the dust, and washing it damages it. You may have a vacuum cleaner with a washable filter and a HEPA filter, but these are two separate filters, and if the HEPA filter is quite expensive, then you're less likely to want to replace it as regularly as you should, and the commercial options I saw were a bit pricier than I liked. Fortunately, everyone's favourite Swedish furniture giants can undercut the competition here and give us a cheap option. This is an upward-wind air purifier, Ikea's cheapest one. It only has a HEPA filter and not a carbon filter, but the replacement filters are quite big compared to those used in recirculating air filter projects at 20 by 25 centimetres, and each filter only costs £3, less than the small HEPA filters in my Nevermore. They also last for 6 months. Nice and cheap. However, the upward wind itself has no way of connecting to an air duct. This 3D model on printables from Julian allows you to connect the output of an upward wind to a duct, but not the input, so this is where I decided to make something myself. And so this is Mafuchit. It's a modular box that you can print on any printer with a Prusa-sized build plate, 250 by 210mm, or bigger. Sadly, the dimensions of the filter itself don't quite let the project work with an Ender 3 size bed as well, but you could separate pieces into 2 parts in your slicer and assemble afterwards. Because of the weakness of printed parts over big objects, the box is designed to be printed in sections and assembled rather than one big print, so we get the best strength from the layers on all walls. You can use glue to assemble the box, but I wouldn't recommend it. I designed this project to use heat-set inserts and screws instead, to allow you to make changes later on. The specific bill of materials is on the Printables project page, but for those in the know, it's Voron Spec M3 heat-set inserts and countersunk M3 screws, so as to remove as little material from the box as possible, while keeping outer surfaces smooth but thick. You could totally use other types of M3 screws or bolts if you needed to though, they just stick out a bit. The walls are quite thick at 4mm, but this is to make sure that the box won't break and cause a leak. I don't want my important safety thing to be so fragile that it might leak if I look at it funny. Of the 3 common 3D printing materials, I'd suggest using PETG for this project. The toughness will help it survive in the real world, we don't need the rigidity of PLA, And with big panels, a small amount of ABS warping may make the joints have leaky gaps, which would be a problem. Those thick, durable walls do mean this project uses quite a bit of plastic, but it also means you don't need top-tier material. If you hunt around, you can get usable cheap stuff for $10 a kilo or less, and that'll work fine for this. Got a bunch of unfinished spools of filament with 200 grams left on them? Each panel will use that much or less, so you can have your very own Technicolor dream box, dreams not included. Even if you have an annoying number of print failures like I did with this. Seriously, nothing due to the model, I just had all sorts of weird issues. My printer even died at one point. Those failures won't scrap the whole model, and you're paying less than commercial offerings even before considering the consumable costs of the filters. I've printed mine in white for a few reasons. It'll draw my eye a bit less, ignore the big black mixed flow fan next to it, and keep the inside bright to make it easy to inspect. But I'll also be able to see if any areas downwind of the filters look dirty over time, so I can make sure there are no leaks. I also printed it with an unhardened nozzle for the best extrusion adhesion. Tougher box, fewer leaks, good times. The lid is kept on with magnets and has this finger hole to make removal easy. And there is writing on the lid to help you keep track of when you need to replace the filter and with what, with multi-material and non-MMU versions available. I don't have a printer with automatic multi-material stuff going on, but the MMU text is only 0.2mm thick, so it's just one material change. I can do that manually. The space here is for you to write on when you put in the filter so you don't lose track. Don't have a Sharpie? Write the dates on a label and stick it on here. Don't have a label? Write it on a bit of paper and tape it on. Don't have any tape? Add a reminder on your phone and nail it on. I've designed this so it has a window in the box too, but there are versions of the lid without this if you want to skip the hassle. HEPA filters get visibly dirty through use, and directly seeing this will help remind you to replace the filter and keep your air breathable, especially if you are forgetful like me. Adding the window is pretty simple. Turn-off supports is not needed for any part of this project. Print the first 3mm as usual, then have the printer pause when it gets to the point of covering up the window. Add a piece of cheap acrylic that is 150 by 100mm and is 2mm thick into the space provided. I got 20 pieces for just over £10, so I've got several for future projects. When I printed my beta version, even though the acrylic was not touching the heated bed, I still somehow ended up with acrylic permanently attached to the build plate? Oops. That's why I'd also suggest dropping the build plate's temperature as much as you dare, and to be extra super safe, I added this tape into this area beforehand. Most sellotape is polypropylene, which has a glass transition temperature of over 100 degrees Celsius, so it should be fine. Slap some tape down, use a knife to cut away the excess, then put the acrylic window in place. The space for the acrylic means you do not need to cut it at all, but you may need to glue it in to keep it in place for the first layer. Be careful if you use superglue, as at these temperatures it is at best a strong irritant. Glue stick will probably work fine. You only need to keep it in place briefly. I was printing this after being awake for too long and couldn't find my glue stick, so I just used some tweezers to hold down the window while I did the first layer. The PETG bonded straight to the acrylic, though other materials may not. The slicer treats it as bridging, so it goes slowly, and it only needed one layer to keep the window in place. Just make sure you don't drop the print bed's temperature so much that the print comes off the bed. Once the acrylic is in place, continue the print as normal, and the window will be enclosed within. Let's see if the tape protected the build plate. Perfect! As we want to see the side of the filter that the air is entering from, I've designed two variants so you can pick where you want the window. These are the slash and backslash variants. If you look at my final version from the front, the HEPA filter looks like a forward slash. That's the slash variant. My prototype has the window on the other side and the filter going the other way. That's the backslash variant. So you can pick the version that lets you see how dirty the HEPA filter's upwind side is. If you're not going to use a window, then it doesn't matter. Just stay consistent. One lid, one base, and two sides. The sides are rotationally identical, so you can print the same one twice. I've also made versions of the base and sides that will allow you to mount this straight onto the wall if you want. And since it's a modular box rather than one big print, you can change it to fit your needs down the line. Finally, we have the in and out section size for 100mm or 4-inch air hose. There are additional versions with 120mm and 140mm fan mountings on it as well. If you want different sizes of air duct, then you're in luck, because step files for all of the model parts are included. I had a 140mm fan dust filter spare, and this was an easy, really lazy way of letting me add it to the mix, keeping bigger dust out of the HEPA filter. Want to add something different to the box? Go for it! That's the benefit of it being modular rather than glued or printed in one go. In fact, I took advantage of this myself. I mentioned earlier that there are two kinds of nasty when it comes to air. The core Mafuchit box only includes a HEPA filter, which is a good start, but I want a filter for VOCs as well. Ikea do have air purifiers that use disposable HEPA and carbon filters, but using one instead of the upward filter would make Mafuchit bigger than most printers can handle, and the cheapest option for a combination filter is £15. Replaced every 6 months, that adds up. I decided to go cheaper and try this filter also from Ikea. It's a Nittig-Vil 559 washable carbon filter that is for a cooker hood. Ikea sells this for £30 and says it will last for 3 years, but needs washing every month. The add-on part for this simply screws onto the existing box, and I can use the same hose connection plate as before. Along with the add-on components, I need to print this section spacer as well. The screws simply pass through it and allow you to attach the add-on to the core section, with the space in the add-on allowing for either screws or hex nuts, depending on what the assembly needs without losing modularity. The cartridge supports the filter, so it doesn't bend out of position. And if I can't get the same filter in 3 years' time, I can make modifications without replacing the whole thing. I'm glad I added a place to remind myself to get a new filter in 3 years' time, and wash it every month? Wait. Oh bother, I need to wash the filter. Let's go do that now. Ikea says to use a dishwasher at its highest temperature, but I don't have one, so I'm just going to spray it with a hot shower for a bit and hope that's enough. It feels quite fragile, so I won't scrunch it or anything. After that, you need to cook it at 100 degrees Celsius for 10 minutes to reactivate it. I'm sure domestic ovens will be fine for this, but I've just finished making my own DIY lab oven, so this is a perfect use for this. I'm planning on making a video about this soon, so please subscribe if you would like to see that or other projects of mine. I want to do more of this kind of thing. There, all done. Of course, you may want to use different carbon filtration media for this task, such as pellets, and that's a strong point of the modular box. You can easily add on your own option or change your minds later on. If I can't get this same carbon filter in 3 years' time, I could make a slightly different cartridge to hold pellets or a different add-on instead. And if you have the carbon filter downstream of any metals, you don't need to worry about acid-free carbon like you would in a filter inside your printer. I do appreciate getting to use the cheap stuff. All the cool kids seem to be putting the HEPA filter downwind of the carbon filter, and I figured that's probably for a reason, so I've done the same. But you can do what you want. I'm not your manager. Unless I am, in which case, get back to work. So now I've hooked up my printer that is fully enclosed to this. For now, I'm using cheap PVC flexible ducting, but that doesn't appreciate higher temperatures, so I'll replace it at some point, at least for the first section. My X Plus has its own exhaust fan, but I've added this cheap mixed flow inline duct fan to help move the air through the filters. At some point I'll add this T-junction and maybe some blast gates, so my switch wire can join in the filtered exhaust fan too. If I wanted to make my own active part of this box, I would probably use a blower and not an axial fan. Blower fans have higher static pressure, which helps them move air through the filters more easily. Axial fans move more air in total. Mixed flow fans try to strike a balance between the two, which is why this type of fan is typically used for moving lots of air through filters and long ducts in other ventilation situations. Because the box is modular, I could easily add on a fan of any kind should I choose to. Now I can blow the cleaned air into Mother Nature's face, and hopefully she appreciates my hard work. Though when it's colder and I don't want my window open all the time, I would have no problem using this without sending the air outside because the whole filter thing actually works really well, and I'm pretty sensitive to smell. Oh, and the outlet I'm connecting the hose to, that was a quick and easy remix I did of this model by Thomas on Printables. Because I live in the country with rain, I added some slats to the window outlet so rain doesn't make its way in. Doesn't stop reverse airflow, but there's probably some model or products for that elsewhere already. That's a future FNEP problem. A friend of mine who works with HVAC systems pointed out that ideally any fan should be downwind of any filters. This makes sure that any leaks in the airflow system go inwards and not outwards, and keeps the fan cleaner for longer. Not always doable, but definitely worth considering. Good point, thanks. Any fan needs to have enough oomph on the upwind side, aka suction pressure, to overcome the filters, so be aware of that. If you do put a fan after any activated charcoal, remember to consider non-acid-free charcoal's ability to rust up a storm. So that's Mafuchit, my air filter box. While I made it specifically for 3D printing, it can be used for anything where you want an inline air filter in some ducting. Resin printers and laser cutters come to mind. I might use one to get clean air from outside, since I live near a busy polluted city road. There are lots of uses for this, and the combination of around a kilo of cheap filament with cheap Ikea air filters makes this very cost-effective compared to other options. What will you use it for? Leave a comment down below and let me know. Did you enjoy this video? Please click the like button if you did. I wanted to have this project in a video roundup of a bunch of things I haven't released yet, but while I still plan on doing that video and releasing those projects, I thought this deserved its own video and should be released sooner rather than later, though it did still take me a while. I've got more projects that I want to do, so please consider subscribing. I would also love to hear if there's anything that you want to learn more about that I've touched on in this video. For now, I'm FNEP. Thank you for watching.